Good morning, dear students. Welcome back to our engineering mechanics class. Aji jai ame offline mode re class koruthile, but aji thu ame ei platform re online platform re patha padiba. Au mate laguchi you people are enjoying this. Okay? So coming back to our topic, ame engineering mechanics re bahut gudai concept jani sarichu. Okay, so from the beginning we have studied about many fundamental concepts of engineering and also physics. Okay, and in that journey we have come up to the point where we have learned about the forces, okay, their representation, their effect, and the system of forces, right? In our previous lecture we have discussed about system of forces, right? If you can remember, I have told you that this forces can be divided into forces in a plane and forces in the space. Okay, we have seen 6 categories of forces. Okay, now in today's class we are going to talk about the composition of forces. Okay, so what is composition of forces? Composition of forces is the process where we find out a simple force which can replace a system of force and that will be equivalent in action to the entire system of force acting on a particle. Understand it like this. Suppose there is a body or a particle, as we see in our day-to-day life, okay, is being acted upon by a number of forces, right? We can take any example, right? ମୁଁ କହିପାରିବି ଯେତେବେଳେ ମୁଁ ଏଠି ଠିଆ ହେଇଛି, ଓକେ, ଆଉ ଯେତେବେଳେ ତମମାନେ ସେଇଠି ବସିଛ, whatever you see around you, okay, if you treat that as a body, you will see that it is acted upon by number of forces. Okay, not only a single force, most of the time more than 2 forces are acting on a body. So that body is now said to be in a action under a number of forces, and that set of force which is getting acted upon the body are called a system of force. So in today's class we are going to find out a single force which can do the action of all these forces, okay, which are acting on this body, okay, and that force is called the resultant. Now jodi mu tumku gote real life example debi, suppose your younger brother and your elder sister, 3 of you have gone to the market to do some shopping, right? You went to the shop, you bought a lot of things. Okay, now your bag is filled with so many stuff, right? Now what your sister asked you to carry that bag, okay, tamo bada bhoni tamaku au tamo sanno bhai ko kahile bag ta dharike घर को चलो, right? So तमे आउ तम भाई बैग धरिलो, बैग टा बहुत हेवी अछि, तमे गोटे साइड रे धरलो, तम भाई आ गोटे साइड रे धरले, and you are walking back to your home. So in the middle of your return to home, both of you felt very exhausted since the bag is heavy, right? Now what you expected your elder sister to do the work for you, right? Since both of you are tired, तुम मैंने कौन कलो, तुम एल्डर सिस्टर को कहलो कि we cannot carry this bag anymore, please do this for us, okay? तो तुम बड़ भौणी कौन करिवो, तमे दुई जण मिसी की जत्तिकी बळ लगेकी बैग टाको उठाउतलो, तुम बड़ भौणी सेत्तिकी बळ एकुटिया लगेकी बैग टाको उठेकी चलिकी जिबे, राइट? सो एठी ए सिचुएशन रे कौन हला ना, तुम दुई जण जो बळ प्रयोग करिकी बैग टाको उठाउतलो, से दुईटा फोर्स को तुम भौणी एकुटिया से लोड टाको लिफ्ट कले, ओके? That means the force applied by your elder sister in lifting the bag is the resultant of you and your brother's force, right? Understood what resultant is, right? I think you guys are clear about the concept of composition of force and resultant. Composition of force is finding out the resultant, finding out that single force which can replace, okay, the action of a number of forces. Okay, if ever you have a little more doubt, let me clarify this with another example. Suppose there is a heavy box here. Okay, there's a very heavy box here, and this box needs to be pulled from this side to the other side. So what can be done? Let me hire two people, okay, to do the work for me, right? So one person will be pulling the box from this end, and another person will be pulling the box from this end with the help of two ropes tied to both the ends, right? So both of them will drag the box and they will take it from one side to the other, right? Now, if I'm not having two persons with me, but a single person has to do this work, then how it can be done? I have to get somebody, a person number 3, who can be of equal, okay, in strength to pull the box alone and take it from this side to that side. Okay, so what this person 3 has to do, he has to put a force which can be equivalent, okay, to the action of the forces applied by the previous two persons in doing the work, right? So now the force applied by the third person to drag the box from this side to that side has to be the resultant. That force by the third person is the resultant of the forces applied by the previous two persons, right? Clear? Now, the question arises how to find out the resultant. Okay, basically there are two methods by which we find the magnitude and direction of the resultant. Okay, one is by graphical method and another using analytical calculations to find out the resultant. And since the resultant is a force, we have to find its magnitude as well as its direction. I think you guys are following me properly. I guess everything is clear from your end. Okay, so moving ahead, let us discuss now the analytical method of finding out the resultant. In today's and some upcoming classes, we'll be focusing our discussion on the analytical method of finding out the resultant. And one such method which helps in finding out that resultant is by using the parallelogram law of forces, right? Parallelogram law of forces. So according to this law, okay, what does this law says? That if we have got two concurrent forces means forces which are acting at one point or which are intersecting at one point. Okay, so if we have got such forces with us which are concurrent in nature and their number is 2, okay, and they are acting in a single plane, then if in that case, if we can represent those forces, okay, in magnitude as well as in direction by the two adjacent sides of a parallelogram, then the resultant of those two forces will be given by the diagonal of the parallelogram passing through the intersection of the two sides or two forces. Sounds complicated, but believe me, it's not. It's very easy. So we'll see how we can find out the resultant using parallelogram law of forces. But before that, let's see what will be the resultant, magnitude of the resultant. The magnitude of the resultant will be given by this formula, okay, which is p square plus q square plus 2pq cos theta. and the direction of the resultant, okay, with one of the forces, okay, will be given by tan alpha, and that is equal to q sin theta upon p plus q cos theta. Now ask me what p and q are. P is one force and Q is another force. Okay, I told you that if there are only two forces, we can use this law, and I have two forces named P and Q, right? And theta is the angle between the two forces. Theta is the angle the two forces are making with each other, right? And okay, we have gotten the formula for the magnitude and direction of the resultant, right? So moving forward, let's see how we can find out this, how we got to those results, right? What I told, the law says that if we have two forces, suppose I have a force like this, okay, let me name it P, okay, and if I can represent this by vector OA, and there is another force Q with me, right, which can be represented by the vector OB, and the angle between them is, let's say, theta, right? So it looks like I can form a parallelogram using these two forces as the two sides of the parallelogram. Yes. How can I do it? I'll complete the parallelogram by drawing parallels. Okay, I'll draw a parallel at point A, okay, which will be Q, and another parallel to P at B. Let both of them meet at point C. Now, OACB is our parallelogram. So, according to the law of parallelogram, what will be the resultant? Resultant will be the diagonal which joins O and C, okay, comma point, and the resultant has to pass through the intersection of the two forces. Clear? Right. Now, to find out the formula for the magnitude and direction of the resultant, let us produce this OA. I have produced OA, and let me drop a perpendicular from C upon OA extended to meet at D, right? Perpendicular draw kali from C to D, and that perpendicular OA produced, OA extended ko D point re cut kala at 90 degree, right? So I have gotten a triangle here. I have gotten a triangle CAD, okay, and this is a right angle triangle. Since this side is Q, okay, OB is representing for vector Q, I can draw like this, okay. This will also be Q, follow me. Since this is PA, OA is PA, this will also be P. Am I clear? Okay. Now, coming back to our triangle CAD, in triangle CAD, okay, what we can write, if we put the Pythagoras theorem, this is the hypotenuse, okay, this is the perpendicular, and AD is the base. So I can write AD, okay, is equal to Q cos theta, and CD is equal to Q sin theta. Follow me? Yes. Now, with this much thing in our hand, let us jump to another triangle, this triangle. COD. Let's consider triangle COD. Okay, so in triangle COD, That is also another right angle triangle. So in this right angle triangle, COC, okay, square can be written as OD square plus CD square. Am I clear? Right? So here OC represents what? The resultant. So resultant square is OD square plus CD square. And if you can closely look at this side, you can see that OD is equal to OA plus AD, right? OD vector is equal to OA plus AD. OA is nothing but P and AD is Q cos theta. Do you all follow me? Yes. So by plugging in these values here, what I get, OD square is P, sorry, I'm so sorry. Oh. Okay. OD square will be P plus Q cos theta's whole square plus CD is Q sin theta. Got my point? Okay. Now applying A plus B's whole square formula, I'll get P square plus Q square cos square theta plus this term becomes Q square sin square theta. Sin square theta, right? So from here we'll get that, see, Q square cos square theta plus, oh, oops, I left a term here. So this, when we open this, it will become P square plus Q square cos theta plus 2PQ cos theta. Let me write down it here. 2PQ cos theta. I'm so sorry, I forgot this term. Now, this Q square theta plus Q square sin theta, if we take Q square common, we are left with cos square theta plus sin square theta, and that will give us 1, right? So what I am left with finally, P square plus Q square plus 2PQ cos theta. What is R here? R square is this much, and so R would be root over of P square plus Q square plus 2PQ cos theta, right? Okay. I think all of you are clear on how we could get into the formula for the magnitude of the resultant. Now it's the time to find the angle. Okay, let's take that this resultant is making an angle alpha, okay, with force P, right? Got? Alpha is the angle between the resultant and one of the force, let's say P. So in the same triangle OCD, okay, tan alpha, I can write tan alpha is how much? This CD upon OD, CD upon OD. What is CD? We have already gotten Q sin theta. And what is OD here? OD is P plus Q cos theta. So tan alpha is this much. From here we can say alpha would be tan inverse Q sin theta upon P plus Q cos theta. I think all of you are now clear about how we have got the magnitude of the resultant and the direction using the law of parallelogram, right? Clear? Let me remind you once again that this method, okay, this process of finding the resultant is applicable in case where you have only two forces, okay. You have got two forces with you, and those two forces has to be concurrent in nature and acting in a single plane, okay. The plane of application or action of those two forces has to be in a single plane, and the two forces should be acting at a point, okay, simultaneously at a point. If the forces are parallel in nature, then we cannot use this method to find the resultant, right? Okay, I think this much is for today's class. We'll be meeting in the upcoming classes to discuss about some of the special cases of this particular law, and we'll be working out some numericals to strengthen your understanding about this topic. Clear? So for now, let me sign in. Bye. कितने समय